Yes, welcome back to the next part 3 on the same content. So as of right now, we have been discussed the network layer, and coming to the next one, just see the position of the network layer. Above network layer, there is a transport layer, and below network layer, there is a data link layer. So right now, my data is going to the data link layer right now. So coming to the data link layer, what is the main responsibility of the data link layer? The data link layer is responsible for moving frames from one hop to the next hop. In the last previous class, I mentioned frames. Frames nothing but our content only. If suppose I'm having 1 GB of data, it is going to be divided into 10 parts. So each part we are naming it as a frame. It's a small piece of information. Small piece of information. Remember that the data link layer is going to be responsible for moving of frames from one hop to the next hop. Hop nothing but this is a complete network. This is a complete network. There is three systems A, B, and C and D. I want to communicate from A to C. I want to communicate from A to D. A to D. This is a complete network. I want to communicate from A to D here. So how my data will pass? This data link layer is responsible for moving of frames from one hop to the next and from these to these. So the data doesn't directly go to the D system. It goes to the C and from C to the D. So when it goes from A to C and A to D, we need to add these addresses inside the packet. We need to add the addresses inside the packet. So what type of address we use at the data link layer? In the network layer, we use the IP address. In the data link layer, we use the MAC address. MAC address is nothing but a medium access control. And simply we name it as an physical address also. Physical address also. Physical address is a constant address. It doesn't change in the network. It's an unique address. But the IP address, IP is an internet protocol, or another name for the IP address is also a logical address. IP address or logical address, both are same. These logical addresses will be changed from network to network. It will be changed by network to network. But the MAC address is a constant address. It's a unique address. It doesn't change completely unless when we are going to be change the NIC code. NIC code is nothing but network interface code. There is one NIC code for every networking device. When we can change this NIC code, automatically we are going to be we can change the physical address. It's a network interface code. So physical address is a constant. It doesn't change throughout the complete network. So this physical address is going to be added the data link layer. Adding at the data link layer. Just I'm going to be show you one example here. So right now, A is my source and F is my destination. I'm constructing the packet. It's my original content. Here it's a source field, it's a destination field. In the source field and destination field, what should be I add? A is a source defaultly. And coming to the destination, can I add F or can I add the B? I'm going to be add the destination system as an B, because this data link layer is going to be it's responsible for moving the packet from hop to the hop. Moving the packet from hop to the hop. So what is the next hop to the B? The next hop is an what is the next hop to the A? The next hop is an B. Hop nothing but next device. Next device. Clear? And when my packet receives to the B, right now, the source address is going to be changed and destination address is going to be changed. The source address now is an B and the next one is an E. The destination next one is an E. So my packet receives to the E. When my packet receives to the E, the source address is going to be changed to E and destination address is going to be changed to the F. So like that, the data link layer is responsible for moving my packet to the next hop And remember, the packet doesn't directly receives to the destination system. My packet need to be undergo through many number of systems. These number of systems we name it as an intermediate systems or intermediate devices Clear? And we see this flow control, error control and access control. These are very important. We talk about in the next coming classes. So right now my data goes to the going to the next last layer, that is a physical layer. What is the main responsibility of the physical layer? The physical layer is responsible for moving of individual bits from one hop to the unhop. Individual bits nothing but from data link layer I am sending the data in the format of frames. When the frames receives to the physical layer, the frames are dividing to the number of bits. The frames are dividing to the bits. It's nothing but zeros and ones. So this is the main responsibility of the physical layer. The physical layer is going to be divide the frames into the zeros and ones. So the mechanism and representation of bits, yes, it represents the bits, and data rate and synchronization bits. These are all the mechanisms, and line configuration and physical topology and transmission modes. So just we talk about all these mechanisms here. Representation of bits nothing but we are representing the frames in the format of bits, zeros and ones. And coming to the data rate, what is the data rate here means the number of bits transferred per second. The number of bits transferred per second. The number of bits transferred per second is said to be in data rate. So I am sending 2 GB of 2 gigabits of data per second means my data rate is in 2 GB. And coming to the synchronization of bits. Yes, we are adding synchronization points here also. We are adding synchronization points here. So we are representing the synchronization of bits here. And line configuration and physical topology. These two things comes under the same criteria, physical topology. So below of the physical layer, there is no another layer, just only the directly there is a network. Just when I am going to be send the data to the network, I am going to be check this one. I am talking about the physical layer. The physical layer is going to be check what type of topology is there inside the network. We already seen that topology is nothing but the physical structure of the network. The physical structure of the network is said to be in topology. The physical structure of the network is said to be in topology. So what type of topology is there inside the network? So if suppose there is a mesh topology means according to that the physical layer does the data and sends to the mesh topology. If suppose the topology was an bus topology means according to that the data will be constructed and sent to the bus topology. Why it is going to be talking about the physical topology here means what type of topology inside the network, because of in below of net physical layer there is no other layer. Directly we are moving the data towards to the network. So the network having different type of topologies. So basing upon the different types of topologies, we are constructing the data here. So due to that, I am going to be study the physical topology in the physical layer. And what about the transmission modes is that topology is following simplex or half duplex or full duplex So just recall what you have done in the last previous sessions, there are three different types of transmission modes. One is in simplex, half duplex, and full duplex. Simplex, just I recall, simplex nothing but we transfer the data from one way only. It doesn't accept from the two ways. So we need to check what type of transmission modes are there inside the network. And half duplex, it accepts the data in two directions but not simultaneously. And full duplex, it accepts the data from two directions simultaneously. So we need to check what type of transmission modes we are using here, right? Okay. And see this data link layer, and this is an physical layer, and below of the physical layer there is only the transmission medium. It's nothing but direct network. So that's why we need to know about the network, what type of physical topology is using, and what type of transmission modes it's using here. We need to know about all these things because we are forwarding all the bits through the transmission mode only. So this is a complete sending part and this is a complete receiving part. So right now, when we are sending any packet, first we encounter the application layer and last we see the physical layer. But when the packet receiving to the receiver, first we encounter the physical layer and last we see the application layer. Right now, we are coming, see here. This is a sending part and this is the receiver part. Sender and receiver. And all these H7, H6, H5 and all these belongs to the header. I already mentioned at every layer, after the completion of all the processes, the layer is adding its header. 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 Clear? And coming to the data link layer, observe that. Coming to the data link layer, there is an T2. What is T2? It's a trailer. It's a trailer. So at every header, we are adding some important information. And coming to the data link layer, the data link layer is adding header and trailer. What the trailer consisting of means, it consisting of some information which was related to the error control and flow control information. Flow control and error control information. And this part was over. And after the passing of data through the transmission medium, it receives to the receiving side. When the data receives to the receiving side, first we encounter to the physical layer. So whatever the header we are adding at the physical layer, the header is removing at the physical at the receiving side. And the same thing, the data goes to the next layer above of it, that is a data link layer. What we are adding here, H2 and T2. That H2 and T2 was removing at the receiving side, and the data goes to the next layer, that is an network layer. What we are adding at the network layer, that is a header 3. We are removing that header at the receiving side, and same thing, it goes to the next layer, that is a transport layer. We are removing H4 and it goes to the data link, it goes to the transport layer, sorry, it goes to the session layer. We are removing the header here and it goes to the next layer, that is an presentation layer. We are removing H6 and it goes to the next layer, that is an application layer. We are removing H7, and at last only the original content goes to the receiver. And no need of all the headers to the receiver, just we are removing all the things at the receiving side only. So in this way, our data passes to the network. If any small piece of information we are forwarding, that piece of information will go to all the layers, that passes to all the layers, that goes to the receiver. So this is a process we are using at the OSI reference model. OSI reference model. Next, we are going to be see about one more layer, one more network model, that is an TCP/IP model. See here, it's an TCP/IP model. TCP/IP model is nothing but transmission control protocol. This is another network model, that is a second network model, that is an TCP. Just I give you some introduction about TCP, and remaining we see in the next coming video. TCP stands for transmission control protocol. Transmission control protocol. So in the OSI model, we see about 7 layers. And coming to the TCP, we see only the 4 layers. We see only the 4 layers. When we talk about TCP, we are having only the 4 layers. That is an application layer, transport layer, network layer, and physical and data link layer combined as an one layer here. When we check individually about TCP, we are having 4 layers. And when you can compare with OSI model, we are having 5 layers. That is a physical layer, data link layer, network layer, transport, and all these 3 layers as an one layer. That is an application. So physical layer, data link layer, network layer, transport layer, and application layer. So presentation layer and session layer, that belongs to the application layer only. So I'm going to be compared with the OSI model here, because we already done with the OSI model. So when you can talk about individually about the TCP/IP, we are having only the 4 layers. That is only the 4 layers. That is an physical and data link layer as one layer, network layer as one layer, transport layer as one layer, and application layer as one layer. So when we can compare with the OSI model, it's having 5 layers. Remember the differentiations. When I can talk about the TCP, it's having 4 layers. When I can compare with the OSI model, I'm having 5 layers. The 5 layers are physical layer, data link layer, network layer, transport layer, and application layer. So see here, whatever the process and whatever the application, whatever the process and whatever the mechanisms we do at the physical layer, the same process we do in the physical layer of TCP/IP. And same thing, whatever the applications and whatever the mechanisms we do at the data link layer, the same processes we do at the data link layer here. And coming to the network layer, the same mechanisms what we do at the OSI model, the same thing we do in the OSI model, but we are having some prototypes here, some protocols here. Some commands, some mechanisms are there apart of that. IP stands for Internet Protocol, and there is an ICMP, Internet Control Message Protocol, and IGMP, Internet Group Message Protocol. These are some protocols inside the network layer. And RARP, Reverse Address Resolution Protocol, and ARP, Address Resolution Protocol. And coming to the transport layer, and there are 3 protocols here. One is an TCP, and one is an UDP, and one is an SCTP. What is an TCP here? These are very important protocols here. TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol, and SCTP stands for Stream Control Transfer Protocol. And coming to the application layer, remember the thing? Application layer is made up of 3 layers: session layer, presentation layer, and application layer. When I can compare with the OSI model, when I can compare with the OSI model, this is the thing. So it's having some protocols like SMTP, FTP, HTTP, DNS, SNMP, and Telnet, and so on. What is an SMTP? Simple Mail Transfer Protocol. What is an FTP? File Transfer Protocol. And what is an HTTP? Hypertext Transfer Protocol. And what is an DNS? Domain Name Server or Domain Name System. What is an SNMP? Simple Network Management Protocol. And Telnet is an Unix command. There is no expansion for this. So there are some protocols which works at the application layer, and there are 3 protocols which works at the transport layer, and there are 5 protocols which works at the network layer. And coming to the physical and data link layer, there is no protocols here. There is no protocols. And the same thing I mentioned here, the same thing I mentioned. Just check all these slides. So remaining in the next coming session, we talk about all these protocols. Okay, thank you.